We have seen how flip-flops can be designed. We can also include additional inputs in the flip-flops to set or reset values stored in a flip-flop. Now, applications of flip-flops include designing counters. So you can design counters using flip-flops. A counter is a digital component which can count in a specific sequence. For example, you can have a counter which starts at 010. When you give a clock pulse, it is going to count 110. When you give another pulse, it's going to count to 000. And when you give another pulse, it's going to say 011. And when you give another pulse, it can come back to 010 and it can continue the process. So how do you design such systems which can count in this pattern or any other pattern? So a counter typically looks as follows. It's going to be a block. It has two inputs. The first input is the reset input, and the second input is the clock input. And for this example here, it's going to have one output Q, which is 3 bits in size. So essentially, when you set reset as 0, then you're going to go into 010. So that is where you start. And when you give a pulse, you're going to move to 110. When you give another pulse, you move to 000 and so on. So how do you design these systems? There are several steps which are involved to make counter designs. So the first step is identify the number of flip-flops required and their type, which means do you want to use D flip-flops or do you want to use SR flip-flops or JK flip-flops or T flip-flops? Now, to identify the number of flip-flops required, all you need to do is look at the sequence. Now, this sequence has 3 bits, which is 010. So we are going to use 3 flip-flops. More specifically, we are going to use 3 D flip-flops. You can also use 3 SR flip-flops or JK flip-flops or T flip-flops. It is totally the designer's choice. For starters, we are just going to deal with the most simplest or the T flip-flops. So in this case, we need 3 flip-flops and they are D flip-flops. The second step is we need to construct the state transition graph. The third step is come up with the excitation table. Step 4 is using the excitation table, find the for flip-flop inputs using K-maps. Once you have the K-maps, you can draw the circuit. Final step is implement it in VHDL. So these are the series of steps. We are already done with step 1. Let's go through each of these steps in a more detailed manner.